Okay guys, so I'm going to go over the questions from the study guide. So let's begin. I'm going to try to go through them pretty fast, but I'll try to explain everything as much as possible. Alright, so the first question, the figure below shows a center of dilation and a hexagon ABCDEF. Answer the following questions. So if hexagon, well, this hexagon is dilated by a scale factor greater than 1, okay, that means the scale factor could be 2, could be 5, could be 3, could be 20, could be 1.5, could be 2.7, could be something big, anything bigger than 1. Then what do you know it's true about the hexagon? Well, this hexagon would be the new hexagon after the dilation. So this would be the new hexagon. So what do we know about this new hexagon? Well, this new hexagon will have to be bigger than the original. Bigger than it'll be bigger than the original, or well, you can just call it by its name. It'll be bigger than A, B, C, D, E, F. Yeah, so this one is going to be bigger than the original, which is this one. Now question 2, it's if hexagon, so this hexagon is dilated by a scale factor between 0 and 1. Okay, this would be like a scale factor of 0.1, 0.5. This also applies to fractions that are less than 1, like 1/2, 1/3, 2/3. Okay, so these fractions are less than 1. How do you know if a fraction is less than 1? You can always put the fraction into the calculator and see what it gives you. Let's say that you put a fraction like 5/3, or 5 divided by 3. That gives you 1.6. So 5/3 is actually that would be like a scale factor bigger than 1. Okay, so you can always try out the fraction. Okay, you can try something like 7/4. You may be like, I don't know if this one's gonna be bigger than 1 or less than 1. So you can just type it into the calculator, and 7/4, again, bigger than 1. Okay, something smaller than 1. You can try something like let's say 5/7. Now this gives you 0 point something, some decimal. Okay, 0 point something something. This is smaller than 1. Okay, 0 point anything is always between 0 and 1. So for this particular problem, our new hexagon, this new hexagon is going to be smaller than the original one, which is A, B, C, D, E, F. Alright, so that's it. Now if the hexagon is dilated by a scale factor of 5, then segment E prime D prime will be, so again, E prime D prime, this is the segment after the dilation, and it's asking us like how big is going to be segment E prime D prime if we dilate the shape by a scale factor of 5. So here's ED. Let me get some colors. Here's ED. So if we dilate this by a scale factor of 5, then our shape will get 5 times bigger. So how do you find out how big ED will be after the dilation? Well, you can just do 5 times 8, and that'll give me 40. So how big will ED be after the dilation? Well, it's going to be 40 times as big. It'll be 40. Now we have this one. It's dilated by a scale factor of 1/3. The process is the same. You just want to multiply. Okay, so 1/3 times, but this time it's asking us for AF. So if we look for AF is going to be right here. AF measures 12. If 12 is dilated by a scale factor of 1/3, again the process is the same as 1/3 times 12. This gives us 12 divided by 3, and 12 divided by 3 is 4. So you see this one shrank, this one got smaller. So the answer is going to be 4. And that's it. That's question 1. Now question 2, we want to find the missing values. So we got a right triangle and you're missing a side length. So here's where we want to apply SOHCAHTOA, guys. SOHCAHTOA. Let me write it over here. SOHCAHTOA. So let's begin with the first one. They're giving us this angle. Alright, so opposite to this angle we can find x. So x is our opposite. 17, that's the longest side. So this is my hypotenuse. And I really don't care about the other side, it's not given to us. I just know I'm using the opposite and the hypotenuse. So this is a sine problem, because sine uses opposite and hypotenuse. So I'm going to use sine. So it's going to be sine of 59, the angle, equals opposite over hypotenuse, which is 17. And that's it. Let's leave it by itself. So how do we leave it by itself? We'll multiply by 17 on both sides. This way, the 17 on the bottom and the 17 over here will cancel each other out, leaving me with x equals 17 sine of 59. You want to put this into the calculator. So let's put in 17 sine of 59. And we get 14.57. 14.57. And that's it. That'll be the solution for the value of x for this side length. So this side length measures 14.57. Next one, same process. We are given, this time we're given this angle here. So from this angle, x is my opposite. So this side is my opposite, and again the longest side is the hypotenuse. So this is pretty much an identical problem. I'm using again the opposite and the hypotenuse, and that's again sine. So let's set it up. It's going to be sine of the angle, so sine of 60 equals opposite over hypotenuse. Opposite over hypotenuse, which is 17. It's a very similar problem. Let's multiply by 17 on both sides. So on the right side, the 17's cancel out. So x equals 17 sine of 60. Let's put this in the calculator and see what we get. 17 sine of 60. And we get 14.72. The answers seem pretty close. So we get x equals 14.72. Well, it makes sense. The numbers are the same technically. The angle in this one is actually smaller. So yeah, it makes sense this one will be a smaller solution than this one. But these should be your two solutions for these two problems. Let's go to question 3. Now for this one we're looking for angles. I'm looking for angles, so I should expect to use the inverse functions. Alright, from this angle I have the opposite, and again the longest side, 44 is the longest side, is my hypotenuse. Also, if you don't know which one's the longest side you can always find the opposite to the right angle. So opposite to the right angle, it's 44. That's the longest side. That's my hypotenuse. So let's solve this problem. Opposite and hypotenuse, again, this is sine. So I'm going to use, now I'm sorry for putting the question mark here. You can change it to x if you want to. Because what I'm going to do sine of the angle. And the angle is the question mark. So sine of x equals opposite over hypotenuse. So hypotenuse goes on the bottom. And there you go. I want to leave sine by itself. So what I'm going to do is I'm going to apply sine inverse on both sides. So sine inverse on this side and sine inverse on this side. So on the left side, sine inverse and sine cancel each other out, leaving me with x equals sine inverse of 39 over 44. So now I can take my calculator and put this into the calculator. So sine inverse, there you go, of 39 divided by 44, close parentheses. Make sure you guys always put the parentheses, alright? And that gives me 62.42. It rounds up to 42. 62.42. So x equals 62.42 degrees, right? Because x is an angle. So 62.42 degrees. So that's that one. Same process for this one. Again, we're using this angle. So opposite to that angle, I find 26. And then again, the longest side, it's again opposite to the right angle, or it's the longest side. This is my hypotenuse, and this is my opposite. Sorry guys, I should have put more questions with more variety of problems, but this is again sine. Again, let me change the question mark to a variable. So sine, it's going to be sine of x, the angle, equals opposite over 26, opposite over hypotenuse, which is 33. Alright, so now let's do the same process. I'm going to apply the inverse to both sides. So sine inverse on the left side and sine inverse on the right side. So on the left side, the sine inverse will cancel out with sine. So x equals sine inverse of 26 divided by 33. Let's put it in the calculator. So we get shift sine inverse, you can barely see that, sine inverse parentheses 26 divided by 33, and we get 51.9. It rounds up to 59.99. 51.99. X equals 51.99, and that'll be the solution for the second one in degrees. Alright, so that's the first page. Now the second page, the scary one. Alright, it's this whole shape. Okay, I'm going to try to go step by step on this one. Okay, I know it seems very confusing, but let me see if I want to find the side lengths first or the angles. I think let's go for the side lengths. Right? So finding the side lengths. Here's the thing. You guys can actually apply what I showed you guys for these problems. Remember, like number 2, you can just take this side, and that'll give you a fraction. And then take this side, and that'll give you another fraction. So you would set this up as follows. You can set it up as y over 13 equals 11 over 10. So this one over this one, this one over this one. You just have to follow the order. You wouldn't want to do this one on top and this one on the bottom, and then this one on top and this one on the bottom. And do this one on top, this one bottom, this one top, this one bottom. Or it could be backwards. This one top, this one bottom, this one top, this one bottom. So I want to apply technically something almost identical to that in this problem. So let me show you guys. You guys kind of just have to like see the triangles. So let me actually trace out the two triangles. Well, the triangle that you will see here for the first problem. Okay, what would be that? Combined with this, and right here. So guys, technically here is the first triangle. That's your very first triangle. Okay, and you can see I'm going to be using 7 and A, 16 and 9. Those are my two fractions. That's all I need. So 7 over A equals 16 over 9. And now we can cross multiply. So, and that'll give us, let me do it over here. That'll give us 16a equals 16a equals, and then 7 times 9, that'll give us 63. Then to leave a by itself, divide both sides by 16. The 16s there cancel out, so a equals, and then in your calculator you can do 63 divided by 16, and that'll give us 3.9. Alright, so that's the value of a. That's the value for this side length. So this side length a is 3.9. Alright, so that's that one. Okay, that's one of the missing side lengths, and I would recommend you guys do this as well. Don't just go randomly finding letters. Okay, I would say find the side lengths first, and then find the angles. Okay, there's another side length here. As you can see, b is a side length. It doesn't have the degree sign, so it's not an angle. b is a side length. And you guys kind of have to like look for the triangles. Look for where are the triangles that belong to this b. And look over here. That's one side of the triangle. That's another side of the triangle. And then this is, oops. And then that's the third side of the triangle. So yeah, this is a completely different triangle. Okay, maybe you guys didn't even see it, but there it is. I'm gonna use orange again for this side length. Check. 11 goes with a. Let me in squares. 11 goes with a, but now we know the value of a. Okay, we know a is 3.9. Okay, so you don't have to use a, you can use 3.9. And then b, let me use blue. B goes with 7. So I'm going to use 11 and 3.9 and b and 7. So let's make our fraction. It's going to be 11 and a, or well, a and 11, so a on top, 11 on the bottom, and then 7 on top, b on the bottom. Oh, and sorry, again, we know the value of a, so we don't have to put a. It's, I mean, we don't want to have two letters in our equation, because then it's not going to be an equation, then it'll be an equation, but it's going to be a function, and you're going to have infinite values if you have two variables. You don't want to have two variables, you only want one single letter. Okay, so this was 3.9. a is 3.9. Alright, so that's a. Okay, 3.9. So now we can do cross multiply. That's going to give us 3.9 and b. That's going to be 3.9b equals, and 7 times 11, that's going to give us 77. To leave b by itself, we can divide 3.9 to both sides. So the 3.9 on these sides cancel out. So b equals, so let me put 77 divided by 3.9. And that gives us 19.7. 19.7. So there you go. That's the value of b. 19.7. So b is 19.7. There you go. So we found this one. We don't have to worry about a anymore. We found b. We don't have to worry about b anymore. So that's it. That's the side length. So we still have to find the angles. I think the angles are much much easier. Like just looking at this, look, I already know what's the value of x. X is opposite to 30, so that means x is 30 degrees. Easy one. I can also find the value of z, because z is opposite to 95, so z is 95. Alright, now y, you may be like, oh well, there's no, I don't know this angle, I don't know this angle here. But notice this, that the angle, these three angles right here, 30, the missing one, and 95, make up a straight line. So these three angles should add up to 180. Well, let's see how we can get the answer from that. It's very simple. You just take 180 and then subtract the 95 and then subtract the 30, and whatever you left, that's how much the missing angle is. So in this case, this angle measures 55 degrees. So this angle is going to be 55 degrees. So I had to find this angle to find the value of y. Again, 55 degrees and y are going to be the same thing. So y is 55 degrees. There you go. Nice. Alright, so from here, it's where things get a little more interesting. Okay, because now you got these other angles that are not as easy to find. But that's nothing to worry about. Okay, first of all, we already know the value of y. We know y is 55. Right? We know y is 55. Now we're missing. We want to find h. Okay, I want to find h. Now I don't know this angle here. I know if you look at this right here, I get a triangle, and I know the angles inside of a triangle have to add up to 180. So I know that this angle here, y, is 55. Now it would be nice if I knew this angle. Well, I can actually find out, because notice right here, this angle here makes up a straight line. So this angle 120 and this one, these two angles, because they make up straight line, they're supposed to add up to 180. So from 120 to get to 180, again, you can just take the calculator and do 120. You can do 180 minus the 120, and that's going to give you 60. So this angle right here measures 60 degrees. Perfect. Now look, now I have two angles and I'm just missing one. Well, the thing is, again, it's a triangle. It's a triangle, so these three angles will have to add up to 180. So h is, here's how I'm going to find h. Okay, so it's going to be the 180 minus 60 minus 55. So I get 65. This angle h measures 65 degrees. So 65 degrees. So I know h is going to be 65 degrees. Alright. We're just missing two angles. Alright, W. Be careful here. You just gotta be smart, you just gotta be clever. I know maybe you're looking at this one and be like, well, I'm missing two angles right here. Yes, you are missing two angles if you're looking at the small triangle. But guys, this triangle, we can actually look at it from a different perspective. We can look at it as a bigger triangle. From here all the way here, all the way down here, it's technically the green triangle that I drew first. Okay, so the angles on this big triangle, okay, you don't have to pay attention to this line here in the middle. Even though it goes through the triangle, it doesn't really matter. I'm looking at the big triangle as a whole. Okay, now look at this. Do I know this angle here? I do. It's opposite to 120, so this angle measures 120 degrees. Then, do I know this angle here? I do. It's opposite to 30, so this angle measures 30 degrees. Look at that. I got 120, 30, and a missing W. So this one and W should add up to 180. Well, 120 and 30, that's 150. To get to 180, that's going to be 30. So W also measures 30 degrees. W measures 30 degrees. Alright, just missing R. Now R is actually a tough one. Okay, R is another type of angles that we did a long time ago. Hopefully you guys will remember. Okay, it's part of the alternate angles, the alternate interior, the alternate exterior, and corresponding angles. Alright, I can actually find the angle that would be corresponding to angle R. Now you can even trace it out. Notice the R is this whole thing right here. That's R, that whole angle right there. Well, notice over here, because these two lines are parallel, okay, you can see the parallel symbols. These two lines are parallel, then these angles right here are going to be the same as R. So this is 30, and then Z was 95. Remember, we found the value of Z to be 95 degrees. So actually R is 30 and 95 together. So 30 plus 95 is 125. So yeah, R would be the 30 and 95 together, which that gives me 125. So R measures 125 degrees. And that's pretty much it. That's how you find all of these angles. So you just have to understand that opposite angles are the same. Angles inside of a triangle add up to 180. Angles that make up a straight line also add up to 180. And maybe corresponding angles, alternate interior and alternate exterior angles. Yep. Alright. Now question 5. Alright, question 5, it's finding the midpoint of these two segments. There's several ways to do this. I'm just going to use the formula, which is, I think, the easiest thing to do. Now the formula for midpoint was x sub m comma y sub m to be equals to x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. So this is the midpoint formula. Okay, first thing that I have to do is find out what's x1 and what's x2, what's y1 and what's y2. So from left to right, this point is going to be my x1, y1. So what are my coordinates of this point? Are -1 and -4. -1 comma -4. These are the coordinates for this point. So this is my x1 and this is my y1. Now for this point, I go 5 to the right and 5 up. So the coordinates of this point are 5 comma 5. So this is my x2 and this is my y2. There you go. I have everything I need for the first problem. So I'm going to set up my equation. Again, the x's go together, so the 5 and the -1 go together. So 5 minus 1. It doesn't really matter in which order you put them. Divided by 2, comma, and then the y's go together. So this is a y, this is a y. I'm going to get 5 minus 4 divided by 2. I tend to put the positive first and then the negative because it makes it easier for me. But that's it. So let's simplify this. So 5 minus 1, that's going to give me 4 divided by 2. Now 5 minus 4, that's going to give me 1 divided by 2. So these are my coordinates. I do want to simplify them all the time. 4 divided by 2, that's going to give me 2. And then 1/2, well, that's just 0.5. So this is my final answer. 2 comma 0.5. So technically at 2 to the right and then halfway up, that's the middle. So this point right here, that's the middle point. 2 to the right and half up. There you go. You can see that's the middle. We landed right on the line. Always double check that you land right on the line when you get your final solution. If you notice that maybe you went left, maybe you did something wrong. Alright, next one, same process. Let's find the coordinates of the first point are -2 and 0, because you don't go either up or down. So -2, 0. These are the coordinates for the first point. The second, so again, this is x1, y1. For the second point, I get, well, it's 5 to the right and 5 down, so +5, comma, and then -5 to go down. So this is my x2, this is my y2. Perfect. Can put everything into the equation now. Remember the x's go together, so the -2 and the 5 go together. I like to put the positive first and then the negative. Divided by 2, comma, and then 0 and -5. Because they are the y's, and they go together, divided by 2. So let's see what we get from here. So from the first, it's 5 minus 2, that's going to give me 3, divided by 2. Comma, 0 minus 5, well, that's just -5, divided by 2. Well, then to simplify this, 3 halves, that's just 1.5. And then minus 5 halves, that's just going to be minus 2.5. You can just put these in the calculator if you don't know how to do that on your head. It's just 3 halves, it's just 3 divided by 2, it's 1.5. And then -5 halves, so -5 divided by 2, that's going to be -2.5. Alright. Alright, so these are my coordinates. That's it. This is the answer. This is what I'm looking for. You got the midpoint. Let's double check that that's actually the midpoint. So I'm going to go 1.5 units to the right and then 2.5 units down. 1, 2.5. And there you go. And that does seem to be the midpoint of my line. Alright, I'm going to be looking for this work on the test. Now here, number 6, it's also finding the midpoint. In this number 6, we're not given the graph. We're just given the values. Now this is actually easier. It may seem harder because you don't have the graph, but just label everything. This is your x1, this is your y1, it's x2, and this is your y2. Doesn't matter which one's which, it doesn't matter. So x1, y1, x2, y2. There you go. Put them into the equation. So the x's together, the -3 and the 4 together, so 4 minus 3 divided by 2, comma, and then the 5's go together, so 5 minus 5 divided by 2. So now I'm going to do the math in my head. So 4 minus 3, it's going to be 1/2, so 0.5. And then 5 minus 5, that's going to be 0 divided by 2, that's 0. That's it. Same thing for this one, the x's go together, so 7 and -4 go together, 7 minus 4 divided by 2, comma, and then the -7 and the 5, so 5 minus 7. Again, the order in which you put the numbers doesn't really matter. I just like to put the positive first and then the negative. Divided by 2, this will be equals to 5 minus 4, that's going to be 3, 3 divided by 2, that's 1.5, positive. And now here we have 5 minus 7, because 7 it's a bigger number and it's negative, the answer is going to be -2. -2 divided by 2, that's going to give me -1. Yeah, when the negative is bigger, our answer should be negative. If you notice in all of these problems, look at this one, 1 was a smaller negative, so the positive wins. So this one stayed positive. Again, 4 was smaller than 5, that's why our answer was positive. 2 was smaller than 5, that's why it stayed positive. And this one, of course, 5, -5, 5 is bigger than 0, so the answer ended up being negative. And yep, in this particular example, 7 is bigger than 5, so it stays negative. So these are my solutions for these two. Now, I think we have this, and then we have a second page. So for the second page, this is it. So these ones you just have to like set up the ratios. Your answers should look just like the letters. Like for this one, sine of A. Well, one thing you can do. Let me color code everything. All right. So let's see. These ones are going to be in. This is supposed to be red. It looks black. In red. Okay. So, and these are for the angle A. Okay, angle A. So angle A is in red. So from this angle, this is my opposite. The longest is of course the hypotenuse, and this would be my adjacent. Alright, so let's find the solutions for the first ones. So sine of A. Sine is opposite over hypotenuse. Opposite is A, hypotenuse is C. That's it, that's the answer. Cosine of A. Well, from A, cosine, it's adjacent over hypotenuse, so that's going to be B divided by C. And finally, tangent of A. Tangent is opposite over adjacent. Opposite is A, and adjacent is B. And that's it. Those are my solutions for the first half. The second one, let's do it in blue. Let's do this one in blue. Alright, so in blue, that's going to be from this angle. Right, from this angle, this side is my opposite. The hypotenuse is always the hypotenuse. Sorry, this is the opposite. And of course, the remaining side would have to be the adjacent. So, from B, for B, sine, it's opposite over hypotenuse. So this is going to be B over C. Because B is the opposite and C is the hypotenuse. Cosine, that's adjacent over hypotenuse. So A over C. And for tangent, that's opposite over adjacent. So B over A. And that's it. Those are the solutions for that back page. Alright, now we have these ones. Now, I'm not going to do all of these ones, alright? I'm just going to do maybe, I think maybe I'll just do number 4. I'll do number 4. Okay, let's just do number 4. Alright, so to do number 4, the process is very, very, very simple. Again, choose numbers that go together. So like those two, 13 and 8. And then 11 and H. So let's put the one on the far left first on top. So 13 over 8. Equals, and then 11 over H. And there you go. Let's find the value of H. So cross multiply, I'm going to get 13H equals 8 times 11, that's going to give me 88. So let's leave H by itself. So let's divide both sides by 13. So 13's cancel out. So that gives me that H equals, so let's do 88 divided by 13. And that gives me 6.77. And there you go. That's the value of H. So H is 6.77. Good, perfect. Guys, I want to see the work on your paper, okay? Make sure you show work. The next one, W. I have options for W. I'm just too lazy to use like the new ones that I find because they tend to have decimals and I don't like to use decimals. So here's what I do. I use the values that are already there for me. So like 11, I can put it with 5. Alright, and then 13, because I use 11, I have to use 13. 13, I can put it with W. So let's make this work. So this is going to be 11 over 5 equals 13 over W. Left, right, left, right. That's it. So 11 times W, that's going to be 11W equals, and then 13 times 5, that's going to be, I think it's going to be 65. Let me do it in the calculator. 5 times 13 is 65. Let's leave W by itself, so let's divide by 11 on both sides. So the 11's cancel each other out, leaving me with W to be equals to, let me do 65 divided by 11, and I get 5.9. And that's it. That's W. And guys, this technically what I did here, how I found W and how I found H, okay, how I found this and how I found this, it's the exact same method for all of these problems here on the back, and it's also the same method for this question up here. All right. Now, just to wrap it up, I'm going to do a kind of like a quick scan over the solutions here, so you guys can see the solutions to all of the problems. Okay, that's the first page. There's the second page. Second page. Third page. And then you guys saw, of course, you guys just saw the solutions for number 4. Alright, so guys, that wraps it up. That's the video. That's it.